Hi, good morning, and welcome to the ZP Developer Zone webinar. So we like to do this every Sunday sorry, it's not every Sunday, it's every Thursday at 8 a.m. London time. We have come on early, about 27 minutes early today, so my apologies for that. Now, you can probably tell from the background that I'm doing this from a hotel in the UK, hence I hope the internet's okay, and my apologies for the camera, my apologies for the sound, but we'll move on. So we like to do this every Thursday at 8 a.m. London time. It really is to answer technical questions that have come in during the week. So let's essentially dive straight into it. Don't forget there's our ZP Academy. ZP Academy is definitely going to undergo a refresh and an update soon enough, but you can get free biosensor material in the ZP Academy. Don't forget the webinars. We do have webinars on Julie, which is a cloud database system from ZP, and we do have webinars on Sense It All, which is very pertinent to the webinar this week. That's the Sense It All. Let me go a little bit quicker. Even this morning, we had a reach out from Australia. A group there wants to do a collaboration with us, and it sounds very interesting. We'll probably end up doing that. But that collaboration is actually with the university, so it must be very clear what collaboration means. It often means with non-profit organizations. Obviously, we do offer jobs. We do have a ZP Developer Zone, and we do have our workshops. I will go a little bit quicker, but we'll touch on some of these things. Don't forget the workshops. If you see a link appear, the link is already underneath the video, and you'll be able to click on them and sort of find this. But this is just to highlight that we do have a number of workshops, and they're not just in the UK and Norway. We also have one, for example, in France as well. So if you're looking to really understand electrochemical sensors, electrochemical assays, electrochemical biosensors, then these workshops are really the best place for that. Last week we did have our Scandinavia Sensor Summit, Digitization for a Sustainable Future, which I really think is pertinent to this week's webinar as well, because I'm very interested in Industry 4.0, and I'm very interested in actually improving processes through the use of sensors. So this is definitely this conference, which has now happened, but I will talk about the next phase shortly. But this conference happened, it's very successful. If you see us on LinkedIn, you'll see a lot of material came out from that. So I just want to highlight that, yes, we are going to do another two conferences at least. S Cubed in the UK, which will be on the themes of commercialization of electrochemical biosensors, and we'll also do S Cubed in Norway, which will be on agriculture, sort of precision agriculture. So yeah, those are coming as well. That said, we do have, I've just said it already, but today's conversation is really about process monitoring. And process monitoring these days, it's really thinking about Industry 4.0 for me. So Julie and Sense It All are two technologies from ZP, which are part of our sort of technology stack. I will describe our technology stack actually very shortly. If I was to say it in one word, sensor to API or sensor to application program interface. Again, if a link appears here, then the link will be underneath the video. I'll move them across. So question number one, sensors for UHT milk production. So UHT stands for ultra high treatment. I want to say this is also pasteurization. This is kind of when you heat milk to quite high temperatures. I mean, it's not, they're relatively high temperatures. Not in industry, they're not, but for food production, they're high. And then question number two is much shorter, and it's the difference between our carbon 303 and our Hypervalue screen printed electrodes. I talk fast because I want to get to the kind of, let's say, the meat of things. So in terms of UHT, somebody wants a inline sensors for monitoring UHT production. UHT production takes place between sort of there's a sort of I want to say a sterilization step which takes place at quite high temperature, and it's interesting because milk is this kind of it's this emulsion between, it's got organic material in it like fats and oils, and it also has let's say a lot of water, so it has an aqueous phase to it as well, and it's at high temperature. So it's an interesting matrix, and it's not necessarily straightforward because it can sort of deposit on things. So yeah, milk is I suppose at ZP at least we like challenging problems as opposed to the easy problems. So they want a data capture with sensors in real time, and the things they're interested in is calcium, and I presume this is calcium ions, Yeah, I mean, it's no presumption. I think it's 100% sure that's what they want to do. Calcium ions. They want to do particle size. And I highlight this because in some ways, some of these are kind of almost physical measurements, and some of these are I would describe as chemical measurements. So calcium ions, chemical, particle size. It's almost a physical measurement. pH, chemical, conductivity. The first thing I want to say before I go on too far is ZP adds the most value when we're doing electrochemical tests. Now, calcium, pH, and conductivity definitely fall under that category. And it's not something I'm going to cover today, but we've also been doing some work on microplastics. So even particle sizing is something, or at least particle presence is something we've been working on. Rheology, as they say here, is viscosity versus shear rate. Is the milk? I'm just trying to remember what the center poise for water is, but I think water is about, I want to say 100 CP, but I don't want to get it wrong. But as it is, you can do the viscosity of milk, and I can understand that that would be a kind of quality parameter that people would be quite interested in. And theoretically, you could do it using electrochemistry, but I will touch upon this in the following slide. I think where ZP adds the most value in this is probably the calcium, the pH, and the conductivity. At least that's where our highest technology readiness levels and our highest manufacturing readiness levels are. And I would also say our highest application readiness levels are. So I'll go forward. So the reason ZP exists is because this whole conversation about putting sensors into process, and I've been using this term Industry 4.0, this is really an extension of IoT, the Internet of Things. And the question that just came out, they were asking for viscosity. Well, you could do viscosity really kind of through flow, so that kind of sensor, these kind of sensors do exist. There's lots of sensors around for things like force and mass, whether you've got a leak or not. Electromagnetic fields, there's definitely lots of sensors for that. Gyroscopes, vision systems, touch, again, motion or velocity. Temperature is definitely done. Humidity, acoustics through either the excitation using acoustics or just listening to essentially sound. But what's missing really is the chemical sensors. So it's not readily obvious that you can where to get a calcium ion sensor, pH sensor, conductivity sensor for applications like measuring these parameters in continuous manner in milk. And that's really where ZP comes in. So that was our kind of whole raison d'etre of forming the company. Right, so now when you look at ZP, we've got something like 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. We've got about 39-ish, getting up to 40 sensors just on the website. And this is not all of them. This is just the ones I've kind of we've had the time to do. Now, in particular, if we were just thinking about milk in particular, then sensors that might be interesting are calcium ions, pH, lactose, TAS, totality oxidative status, and also if you're ever wondering about bacterial load in things, ATP, adenosine triphosphate, is also very interesting. But I want to stay on topic today and just talk about calcium, and I realize there's actually one more in here that I haven't highlighted, but it's here. If I can just essentially highlight it with my we also have conductivity as well, so I should just make a point of noting conductivity. Right, so let me go forward a little bit. What I want to do is just highlight this technology. So the important thing, if somebody comes and asks about whether you have sensors and whether it can do it, it's really to discuss the technology readiness level and the manufacturing readiness level. So if somebody came to me and said, I want to measure the pH in milk, I actually would be quite comfortable with that in the form factor of spot testing. So spot testing, obviously, as opposed to continuous testing, is we'll take the drop of, in this case, milk, put it on a sensor and measure it. So I'm quite happy with the technology readiness level. So when I say TRL9, what I'm thinking about is our pH sensor, in my opinion, good and robust, and can we manufacture it in a scalable manner, or do we manufacture it in a scalable manner? So we do have something called the Sense It All platform, and Sense It All is, again, that phrase, sensor to API. So it means that we have a sensor, we have a very elegant piece of hardware that connects to smartphone. The smartphone app drives the hardware. The app receives the raw data from the sensor. That goes to the cloud where we can process it, do quality control on it, make sure everything's good, and we can deliver the result back locally to the person on their, let's say, phone. And we can also store the raw data in our cloud as well. So Sense It All in the video that we're showing is really for spot testing, whereas I say you bring the sample to the sensor, and then we have a whole sort of, how do I say that, whole video around that. And here I can see that the engineer is connecting. And what they're going to do is they're actually, because the term Sense It All means that they can scan a QR code and it will say to them, you know, measure pH or measure calcium or measure conductivity. We can just change the technology or what the technology is about to measure quite readily. And as you can see, the hardware is small and elegant. It has LEDs on it, and these are just to kind of guide the user experience, make sure that the user essentially knows what's going on. Essentially, these are what we call sort of lights to indicate machine status or status of the machine. All that said, in this example, this is coming from the food quality industry. Here, they're putting on a sample of chili, and the engineer will run it and essentially get a result, and they'll also get results into the cloud as well. Right. So that, if somebody said to me, I want to measure pH in milk, that we can have very high. Now I want to touch, and again, if a link appears, and I will drag myself out to the way of this, if a link appears, then I will put those links underneath the video as soon as I've finished this. Now I want to talk about continuous monitoring. So continuous monitoring and new matrices. So when you bring, obviously, the sample to the sensor, you sort of leave behind lots of problems. What I mean by that is the sensor's not just dipping continually into that sample. You're not in the flow conditions and the temperature conditions associated with the sample. You know, no, you've brought the sample out. And to be honest with you, that makes things a lot easier. Now, when you ask a question, I want to be in that sample, that's a whole new, say, area. And so here I've kind of, I have represented that we've done this kind of work where we have to actually put the sensor into the system. Either it's a batch reactor or continuous flow reactor, but you know, there's some sort of flowing system involving pumps, valves. So this is now what I want to say here is the complexity associated with this. So I'm just going to show you. When you look, if you watch this video, what you're going to find out is that in fact the Sense It All platform is exactly the same technology behind this. So here we have the electronics. That's exactly the same electronics that we were using earlier on. As the video shot in there, you can see a QR code. Again, it's the QR code that tells the app what sensor or what are we dealing with here, and then the app configures itself accordingly. There's a sensor in a little flow cell in this particular setup, and we have a couple of valves and a pressure system, because this is how we're kind of essentially pulling the sample out of the reservoir in this particular case, but it could just be flowing as well. And we have a waistline. So putting sensors into flow streams is fine. What it doesn't answer the question is, can you actually make meaningful measurements in that particular flow stream? So it's one thing to, in this case, we're measuring analytes in an aqueous system. Obviously, in this particular inquiry, we're measuring analytes in a milk at high temperature. So you know, that's really, it's the application gap that is the biggest challenge here. So I've got a link to that kind of video here. So I've touched on it a few times, but one of the things that we do at ZP is not only deal with our own technology, but we're also sort of technology scouts. So you know, we're very familiar with technology readiness levels. So this material is from NASA, so I don't want to claim this material, you know, and it's quite nice that NASA has actually, kind of helped to sort of formalize and standardize this. So these the pH sensor, for example, I'm going to keep it simple because otherwise we're going to have at least four parallel conversations on pH, calcium, particulates, and conductivity. Technology readiness levels are high. Our manufacturing is high because we manufacture it. It's the application readiness level that I would be, let's say, concerned about. So what I mean by that is, to have a sensor in a flow stream at high temperature or highish temperature, you really have to prove that out. And so I kind of put it here that realistically, we have the components. So what I mean by that is we have, in the case of pH, we have a pH sensor, we have the electronics, we even have the app and the cloud system, so we can get a continuous stream of data, for example. But you've got to prove it. It's all words until actually somebody's gone away and proven it. And realistically, so there's a proof. It's interesting here because it says a proof of application concept. At ZP, for a long time we've had a proof of concept or proof of principle programs. So it's interesting to see that we're really aligned with the way that NASA thinks as well. And of course, really to roll something out into an end user, especially in the food industry, you've got to get up to 8 or 9. So there's for me, there's definitely a gap in terms of application. So proof of application or proof of concept or proof of principle for ZP, these are projects that we actually do. So I think the first effort when answering the question, can you detect, for just to keep it simple, pH in milk, then it would be we'd have to do a proof of principle to see that quite a deep technology stack that we have is applicable actually in this particular application. So it's not the TRL and the MRL that I'm worried about or concerned about. It's the application readiness level that I'm most concerned about. So this is something that ZP would consult on. So we are able to do what's called, we can consult by the hour, we can consult in micro and mini projects, we can do proof of principle, but of course ZP also gets into full-blown programs as well that can sort of run for multi-years. I'm not suggesting this is that, but we're quite scalable in terms of project size. I am going to change direction now and just do a much quicker question, which is somebody was very interested in our what was called carbon 303s, and then we've also got a Hypervalue carbon electrodes. And they're asking a simple question, which is, what's the difference? Well, the biggest difference for me is price, and price fundamentally comes from our scale of manufacturing. So we're able to manufacture. We do large runs of this, but the fundamental manufacturing unit when we do our 303 is 40 electrodes, where the fundamental manufacturing unit when we're doing our Hypervalue carbon electrodes is 300. So it's almost an order of magnitude more per unit time. We get 300. We get a 10x more sensors per unit time when we're doing the Hypervalue as opposed to just the carbon 303. And that really reflects in the price. That 40 303 electrodes is something like 350 euros. 300 Hypervalue electrodes is 250 euros. And it's just because we're just trying to pass on our savings onto the end user. So if you've got a choice, there's no choice really. I'd just go for this Hypervalue carbon electrode. We use it a lot. And the fact that we use it a lot makes it high volume, and the fact that we have high volume then helps with the cost. If you need to run experiments with our Hypervalue carbon electrodes, I've listed out the equipment here, the anapot, the electrodes themselves, the cable, and the connector. So in summary, question number 1, UHT for milk. If it was spot testing, and I understand this is not what they're interested in, then that's the TRL and the MRL are high, and also because you're bringing the sample to the sensor, the application readiness level is also high. Once you start asking us to be in situ, in flow, then essentially the MRL and TRL on the sensor remains high, but it's the application readiness level, and that would require a program with ZP. And a first step would just be to go into the lab and actually just check the matrix and check the matrix at those temperatures and see if this was, if we were making sense, if I can put that. or this was looked like it stood a chance. And then regarding the second question, which is much easier, the biggest difference between the 303 and the Hypervalue electrode is that we're able to manufacture the Hypervalue electrode much more efficiently. We make much more at a time, and therefore we're literally, because we're 10 times the manufacturing rate, we're actually dividing the cost. Well, essentially the cost is a tenth of on the Hypervalue as opposed to the 303. What I'll do now is just say a quick thank you. Again, the contact us I'll put underneath the video, and I want to say thank you very much. So my apologies again. It's in this hotel. It's an unusual background. In the background, the microphone and the cameras are not quite what I'd like, but when you're traveling, you're traveling. Okay, well, have a good week. If you've got any questions, don't hesitate to reach out to us at ZP. Okay, thanks very much.